Okay. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty, let's find a blank page here and let's go ahead and get started. So these are questions that were requested. This is from section 11.7, number 7, and you can see it over here on the left on the web assigned screen. It says solve the equation e raised to the 3.9 t power equals 9.7. This is an exponential equation, and there is no coefficient in front of the exponential part. In other words, there's no number out here we have to get rid of before we can switch things around. So we can go ahead and change this into a logarithmic equation. And it would be log base e of 9.7 equals 3.9 t. But log base e is natural log, so we got the natural log of 9.7 equals 3.9 t. Dividing both sides by 3.9, we get t equals the natural log of 9.7 divided by 3.9. And when we punch that into the calculator, the natural log of 9.7, close it up, divided by 3.9, we get 0.58259638, etc. It says round your answer to 4 decimal places. So we would round right here. The 5th place is a 9, so that rounds up. So we'll get 0.5826 as our final answer. Any questions on that before we go on to number 8? Okay. Next up, again from 11.7, number 8, and it says, solve the equation, round your answer to 4 decimal places. E to the negative 0.3x power equals 18.6. Again, this exponential equation is ready to be converted to a logarithmic equation. So we get log base e of 18.6 equals negative 0.3x. But log base e is just natural log. So natural log of 18.6 equals negative 0.3x. Divide both sides by negative 0.3, and we get x equals the natural log of 18.6 divided by negative 0.3. So calculator time, the natural log of 18.6, close it up, divided by negative 0.3, and we get, let's see here, negative 9.7438711936, rounding to 4 decimal places. The 8, the next decimal place, the 7 would round up. So negative 9.7439 is the final answer. Any questions on that before we go on? Okay, next up is number 14, again from 11.7. And it says, a sum of $7,000 deposited in an account grows to $10,000 in 5 years. Assuming annual compounding, what interest rate is paid? Now, notice it is not continuous compounding, it's annual compounding. So the formula we're going to use is one of those first ones we looked at, A equals P times 1 plus R over K to the KT power. $7,000 is deposited, so that's P. The account grows to $10,000, so that's A in 5 years, so that's T or time. Annual compounding, so K is 1, and we are to find the interest rate and rounded to 2 decimal places. Okay, so plugging all those numbers into the formula, we get the following. $10,000 equals $7,000 times the quantity 1 plus R, which we don't know, over K, which is 1, to the KT power, which is 1 times 5. All right. We can simplify this considerably. 1 times 5 is just 5, and 1 plus R over 1 would just be 1 plus R. So I've got this, $10,000 equals $7,000 times 1 plus R to the 5th power. Next, I'm going to get rid of the $7,000 from both sides so that I can convert this into a logarithmic equation. So I'll divide both sides by $7,000. On the right side, I get 1 plus R to the 5th power. On the left side, I get 10 over 7. Now, 10 over 7 as a decimal doesn't come out nicely, so I'm going to just leave it as 10 over 7. I'm going to rewrite it so the variable I'm trying to solve for is on the left, just because that's just how I like to do things. So I've got this 1 plus R to the 5th power equals 10 over 7. How do I get that R out of that 5th power? Well, we're going to take the 1/5 power of each side. So basically the 5th root, okay? So on the left side, I get 1 plus R. On the right side, I get the 5th root of 10/7, raising it to the 1/5 power, taking the 5th root. In fact, let's go ahead and leave it as an exponent. We can do it either way. So let's rewrite that, go back to where it was. Hang on. So we'll just leave this 10/7 to the 1/5 power. But I'm trying to solve for R. So now I need to subtract 1 from both sides. So I've got R equals 10/7, the whole thing, to the 1/5 power minus 1. Okay, let's see what we get when I do that. So parentheses 10 divided by 7, close parentheses, the power key, that little caret thing, and then parentheses 1 divided by 5, close that up, and then minus 1. And I get 0.073940924. Okay, now that's as a decimal. As a percent, I would move the decimal point 2 places to the right. So I get 7.3940924%, but the directions say round to answer to 2 decimal places. So that would be there. The 4 would round down. So 7.39% would be the final answer. Any questions about that problem? All righty. Give me a minute here to find another requested problem. So let's see here. Just another minute. 7, 12. Okay. So this again is in 11.7, and this is number 12. So in WebAssign over on the left, it says an isotope of lead. I'm not sure how you say that. 201 PB has a half-life of 8.4 hours. How many hours ago was there 60% more of the substance? Round answer to 1 decimal place. Okay, so this one's a bit tricky because we're going backwards. We know the present amount, but we're going back into the past. we're going to use the formula A equals A sub 0 times 2 to the negative t over h power, because it's a half-life problem. Okay. We know that the half-life is 8.4 hours. Time is the unknown. It says how many hours ago. We don't know the beginning amount and we don't know the ending amount. Okay. But here's the deal. The ending amount is what we're starting with. So we're going to call that A. The amount 6 hours, excuse me, the amount in the past that we're trying to determine how long ago says was 60% more of the substance. So the beginning amount was 60% more than the ending amount. So it would be 160% of the ending amount. Okay, we're going into the past. We've got this amount, but if we go back in time, at a certain time, there was 60% more. So back in time, there was 100% of A plus 60% of A. Okay, so that one's a little trickier than some of the other ones. So now we've got A equals 1.6 A times 2 to the negative t over 8.4 power. All right. I'm going to divide both sides by A, and I get 1 equals 1.6 times 2 to the negative t over 8.4 power. However, before I can convert this to a logarithmic equation, I have to get rid of that 1.6 in front of the exponential part. So we'll divide both sides by 1.6. We get that. Now, 1 over 1.6, if I put that into my calculator, let's see, 1 divided by 1.6. Oh, it comes out nicely. 0.625 equals 2 to the negative t over 8.4 power. So now I'm going to change it into a logarithmic equation. We're going to get, I'm going to go all the way over here, log base 2 of 0.625 equals negative t over 8.4. I'm going to multiply both sides by negative 8.4. So then on the left side, I'm going to get negative 8.4. I'm going to use the change of base formula on this. So then I get log of 0.625, all divided by the log of 2, equals, on the right side, the 8.4 is reduced out, and negative times negative is positive. So the time is going to be this whole thing. So let's put that into the calculator. Negative 8.4, and then let's see, log of 0.625, close that up. Let's see here. Hang on. Yeah. Okay. Divided by log of 2 equals, let's see here, 5.6958, and then it goes on and on, but it says round answer to 1 decimal place. So that would be there, but the 9 would round up, so 5.7. Oh, it's not years, it's hours, isn't it? 5.7 hours, which is the answer right there. Okay. So that's all the questions that have been requested of me so far. Do any of you here now have any questions that you'd like me to look at this point? Nope. Okay. Well, then what I'm going to do is I'm going to switch back to the regular screen. So give me a minute here. Okay. So here we go. Okay, let's do a review of what's in chapter 11. We started out in section 11.3, and in 11.3 we looked at graphing exponential functions. They are in the form of y equals b to the x power, and the base has to be greater than 0 but not equal to 1. And if the base is greater than 1, we get an increasing function. If the base is between 0 and 1, we get a decreasing function. We said the domain was all real numbers. The range is greater than 0, and the y-intercept is at 0, 1. Now, if we put a coefficient in front of that exponential part, then things change. And let's see, if we have a number out here, it moves it up or down. A number in part of the exponent moves it left or right. Let's see, anything else I want to talk about there? That's where we first introduced this formula, A equals P times 1 plus R over K to the KT power. And we did an example of that a little while ago. This is for a situation where the interest is not compounded continuously. So if it's annually or semi-annually or quarterly or monthly, I don't have 12 fingers to hold up, or daily, we use this formula. Okay. Then we looked at the idea of logarithms, and where you can take, this is 11.4, you can take an equation that's an exponential equation and put it in logarithmic form where the base is the same, but the two numbers change their locations, change places. Let's see here. Thing I want to highlight there. We have log base 10, which is written as log, likewise on your calculator. And then 11.5, we introduced base E, which is approximately 2.7. And we said that log base E was written as ln natural log. We introduced the idea of continuous compounding, and that was the formula A equals P times e to the RT power. So if it's continuously compounding, or if it's a population that's growing or decaying, we use this formula as opposed to that formula. Okay. We had the change of base formula, log base B of X equals log base A of X over log base A of B. So the top goes to the top and the bottom goes to the bottom, and you want to use either natural log or common log so that you can punch that into your calculator. We also looked at, let's see, other formulas, one of which we dealt with, which was the half-life formula. Let's see. This one, and we did an example of that a little while ago, where T is time, H is the half-life, A sub 0 is the beginning amount, A is the ending amount. And then we also have a shortcut formula in the situation where something is growing continuously and we want to know how long it takes to double the initial amount. The time would be the natural log of 2 over the growth rate. Anyway, do you have any questions? Anything of those that you'd like me to do examples of or anything? Okay. Well, so no class tomorrow. We'll just be showing up. Well, no, don't have to show up. Take your test, okay? You can take it anytime from now until 11:59 p.m. tomorrow. Just remember, once you open it, the time starts. I will be back this afternoon with an office hour, and on Tuesday, there'll be an office hour. But we won't meet again until next Monday after Thanksgiving. There's no classes Wednesday, Thursday, or Friday, okay? Starting next Monday, all during the week, we're going to be reviewing, getting ready for the final. So on Monday, I'll be focusing on the material from the first chapter test. Actually, it wasn't a chapter, it was 3.7, 4.5, and then 14.1, 2, and 3, I think it was. Anyway, that'll be Monday. Tuesday, we'll do the chapter, I think it's 8, and then Wednesday 9, and then Thursday 10, and then Friday 11, something like that. Anyway, we'll just plow our way through the chapters. So if you come to those sessions and you come prepared, if you have questions, you can email me ahead of time or just tell me when you show up. Anyway, good luck on your test tomorrow. Have a happy Thanksgiving, and I will see you all next week, if not before.